Hello everyone. Continuing our project, today we are doing a deep technical dive into Voterpulse, a real-time political intelligence engine built specifically for the 2029 Indian general elections. Our mission with the platform is massive. We are autonomously tracking, analyzing, and forecasting the political sentiment of over 1 billion eligible voters. We are doing this across 543 Lok Sabha constituencies spanning 28 widely diverse states and 8 union territories. This tool wasn't built just to look pretty. It is designed for political analysts, campaign strategists, and newsrooms who require zero latency data to make decisions without suffering the prohibitive costs and delays of traditional ground polling.
To achieve this, we built a modern, high-performance stack using Next.js 14, custom locally developed, locally hosted, high-performance, high-efficiency data ingestion pipeline for live ingestion and Drizzle ORM backed by an incredibly fast SQLite cache.
So now, let's talk about the core problem as why we are building Voterpulse. So, to understand our architectural choices, we have to look at the severe limitations of traditional polling methodologies. Traditional ground surveys are fundamentally broken for the modern 24/7 news cycle. They are discrete and static, and by the time an agency collects and publishes a 10,000-person survey, the political narrative has completely shifted. Furthermore, the costs are prohibitive, limiting agencies to monthly or quarterly updates. Also, telephonic polling is also suffering from massive sampling bias, consistently failing to capture younger, highly mobile demographics, leading to higher margins of error when exploited to a billion people. And Voterpulse introduces a complete paradigm shift. Instead of asking thousands of people what they think weeks after an event, we utilize continuous ingestion. We sample the live web, parsing millions of unstructured data points 24/7. We build this with a sub-millisecond SQLite caching layer to ensure aggregate data is available instantly. And crucially, we utilize a multimodal validation system cross-verifying LLM output with a pure algorithmic lexicons to dramatically reduce costs while vastly increasing our data resolution. So now, let's look under the hood at a database schema powered by Drizzle ORM and SQLite. Because we are processing dense API payloads, cost control and rate limit bypassing are critical. We built a robust cache entries table that implements a strict TTL-based JSON storage system. This intercepts redundant LLM calls, effectively cutting our API cost by over 90%. We also log a hit count for deep analytics on user query behavior. But the real magic happens in a regional sentiment table. We aren't just storing basic positive or negative swings. As you can see in the schema snippet, we calculate advanced analytics. We track drift velocity and drift acceleration to see exactly how fast political movement is moving. This mathematically models how political sentiment in one region, say a farmers' protest in Punjab, spills over and influences adjacent states like Haryana. Now, let's talk about a dual engine intelligence layer. So, transforming the chaos of the live web into structured, deterministic JSON requires this extreme precision. We accomplish this using a dual engine intelligence layer.
The prime engine is a custom locally developed, locally hosted, high-performance, high-efficiency data ingestion pipeline.
We enforce mathematical normalization, demanding that positive, neutral, and negative scores sum to exactly 1. We also enforce that every claim comes with a verifiable URL. But we do not blindly trust AI. To prevent hallucination, a secondary engine is a lexicon-based analyzer. This is a pure algorithmic fallback running locally in Node.js. It uses an FN-inspired dictionary explicitly tuned for Indian politics. So words like mandate score a +2, while scandal scores a -3. It features hardcode negation handling, so words like not corrupt flip the sentiment token dynamically, and intensity modifiers like extremely apply mathematical multipliers to the base score. Our project also features constraint Bayesian forecasting. This level of constraint carries over to our forecasting engine. When projecting elections results, large language models are prone to devastating arithmetic errors. To solve this, we hard-code absolute mathematical boundary rules directly into the prompt's architecture. As you can see in the excerpt on screen, we explicitly command the LLM that the Lok Sabha has exactly 543 seats, the majority mark is 272, and the sum of the NDA, India bloc, and others must equal exactly 543 using only integers. By aggregating real polling data from agencies under these strict constraints, we generate highly reliable data. The probability and trend outputs are specifically designed to feed into Monte Carlo simulations, generating thousands of randomized runs to produce a narrowing confidence cone. We also dynamically track the health of massive coalitions, tracking how state-level party deflections impact overall national probability. The automated alert engine with severity levels. So, data is only useful if you know when to look at it. We built an automated watcher that constantly scans the live ingestion stream for critical shifts within 48 to 72 hour windows. The system categorizes anomalies by strict severity types. A volume surge is flagged as medium severity. This detects when a specific policy announcement goes viral, logging the anomaly before the sentiment fully crystallizes. A trend reversal is high severity. This triggers when a historically stable state suddenly shows accelerating momentum for the opposition, usually linked to major state rallies, and a sentiment drop is critical. This fires when a breaking scandal drastically shifts a drift velocity matrix, threatening to alter election outcomes. These anomalies are logged in our SQLite database, tracking percentage changed thresholds and enforcing human review via the acknowledged by fields, ensuring no critical event slips past an analyst. For geographical data, the technical innovation is a context injection strategy. The hallucination problem dictates that if an LLM wastes compute tokens trying to recall basic facts like who the current chief minister of a specific state is, it degrades its capacity to analyze nouns. So, inside the mapping prompt, we pre-inject Hard 2026 ground truths. We explicitly tell the model UPCM is Yogi Adityanath, and for other states, the same. We also force total geographical coverage. We explicitly demand analysis for all 28 states and 8 UTs by listing their precise Lok Sabha seat counts and forcing exact ISO codes like in UP. By offloading the factual recall, the LLM's compute power is directly entered toward extracting precise key issues arrays and generating highly substantive 3-sentence metric analysis for every single region. Finally, we had to render this massive, highly complex dataset without overwhelming the user. A front-end tech stack utilizes React Server's components in Next.js 14. This allows us to perform complex database queries entirely on the server, shipping zero JavaScript to the client using until interactivity is needed. We use Radix UI for fully unstyled screen reader complement accessibility primitives and features combined with single maps for highly performed SVG rendering. Our design philosophy, heavily inspired by tools like Faye, is clarity over complexity. We utilize a strict typography first hierarchy. The highly readable interfront is used for narrative analysis, while JetBrains Mono isolates hard data points, API logs, and metrics. Combined with a high contrast deep dark mode, we drastically reduce cognitive overload and eye strain for analysts looking at this data for hours on end. Before we conclude, we must address unit economies and system reliability. Running thousands of LLM queries a day can bankrupt a project if not strictly monitored. That is why we build the API call log table. Every single request to Perplexity or Grok is logged. We track exact prompts tokens, completion tokens, and millisecond latency. This allows us to monitor provider health in real time and calculate exact operational costs per query. Furthermore, if the Perplexity API degrades and latency spikes, our system detects the failure through the success boolean. It then automatically fails over to our local algorithmic lexicon engine to ensure absolutely zero for downtime for the end user. This telemetry ensures Voterpulse remains economically viable and relentlessly stable at scale. Now, to conclude, Voterpulse rests on three core pillars: speed, accuracy, and transparency. We provide sub-millisecond cache reads and versus weeks of pooling, dual engine validation to eliminate hallucination, and explicit source citation for every single claim. Looking to the future, a V2.0 roadmap is focused on hyperlocal resolution. We are working to drill down from 36 state boundaries to map all 543 individual Lok Sabha constituencies. We are also building a social firehouse integration, directly tapping into X, Reddit, and regional platforms to track vernacular sentiment as it happens. Voterpulse represents the bleeding edge of predictive political intelligence. Thank you for joining me on this deep dive. I invite you to explore the source code and try the live platform for yourself.